In step 4 then, with our scientific test, our testing of our hypothesis, we end up affirming the consequent, and that's logically invalid. So deductive reasoning, in fact, fails to give us certainty. What do we do then? We go back to inductive reasoning. Where deductive reasoning fails, we use inductive reasoning. And that, with the combination there, is what we call abductive reasoning. So what do? You repeat the testing process as many times as possible. How do you do that? You make more observable predictions using deductive reasoning. More, if my hypothesis is true, then here's something else I should observe. And if my hypothesis is true, then here's a third thing I should observe. And in each case, you either affirm, you go look for the prediction, the predicted consequent, and you either affirm it if you find it, or you deny it if you fail to find it. Each successful prediction, remember, on its own is logically invalid and does not give you certainty, but together they're going to make a strong inductive argument, depending on how many tests you have. Again, predicting, if the prediction came true this time and that time and that time and that time, then you can reasonably believe that all predictions will come true. And you now have a strong reason to believe the hypothesis is actually correspondently true. It's the way the external objective universe of nature really works. And that was the idea behind 0 plus 0 plus 0 plus 0 plus 0 gives you 85. A series of individually invalid deductive arguments are combined in an inductive way to give us an abductive, a strong abductive argument that gives us a high degree of certainty, but never 100%. Okay? So this is what happens in medical diagnosis. Dr. Karev, based on the empirical observations of the patient, uses deductive reasoning to come up with the hypothesis that the problem is appendicitis. And then the important next step in science is to run tests, to test the hypothesis, to make predictions. If it's really appendicitis, then what are other things we should observe? And this is another part of the medical training, is to know what kind of tests are available and what kind of results come from which particular antecedents. So in this case, he suggests let's get a white blood count, a urinalysis, and an abdominal ultrasound. Well, in appendicitis, he knows that a white blood count should be elevated. So that's the prediction. If the patient really does have appendicitis, then the white blood count will be elevated. A urinalysis should generally be negative. There should be no change. That's a predicted observation. And an abdominal ultrasound should show an enlarged appendix. And so each of those tests is run to see whether the predicted consequent of the antecedent appendicitis is actually found. So Dr. Karev, in his original assessment of the patient, has, let's say, a 60% certainty that the patient has appendicitis. Doesn't want to start treating on the basis of a 60% certainty, and so he makes further predictions, observable predictions. If the patient has appendicitis, the white blood cell count will be elevated. If the patient has appendicitis, then the urinalysis will be normal. If the patient has appendicitis, then an abdominal ultrasound will show an enlarged appendix. These are the predicted observations. And if they are empirically affirmed, each one, again, 0% certainty, but add that to all the other arguments, and you now have, let's say, a 95% certainty. And that's a good basis for treating your patient.